Hi everyone, thank you so much for joining my session about lightweight enterprise Java with MicroProfile. It's been an honor to be here with you today, and I'm really grateful that all of you came, especially after lunch, because usually people get sleepy after lunch. So anyway, I'm just going to talk a little super briefly about myself. My name is Roberto Cortez. I usually work a lot with enterprise technologies, and I'm from Portugal. I'm also the founder of the conference called JNation, so if you happen to be in Portugal and want to spend awesome time over there during summertime, please go to that conference. And please follow any of these links if you want to connect with me, either now or after the session if you have any questions about it. Just recently, I also joined a new company called TalkDesk. They develop contact center solutions in the cloud, so please check them out if you want to know more about them. Anyway, so we're a lot over here, so I'm very pleased to have as many audience, so I'm not sure if this is going to work. I usually like to make my presentations very interactive. If you have any questions, please try to ask me at the context we're talking about. I'm usually, I don't have very good eyesight, and especially with all these lights over here, so I might not be able to see you. So please throw me something, and I'll try to catch my attention, and I'll try to come to you for the question. Anyway, for our agenda for today, we're going to talk a little bit about microservices, of course, because that's what people like, or maybe not. And we're going to talk about what is MicroProfile. We're going to talk a little bit about all the specs overview that we have on MicroProfile. I'm going to try to do a few demos in my box. And I'm not sure if you're able to see these. I have a stack of Raspberry Pis here in the bottom. And I'm going to also try to do a couple of demos there on Raspberry Pis. And I'm going to talk a bit about MicroProfile future and what's happening in the next couple of months and years. So who does microservices over here? Okay, all of you. That's why you're in this session, right? And who likes microservices? Okay, I mean, we are in a safe environment here, guys, so you can say if you don't like it. I mean, no one is judging, right? So, and there's a couple of questions like those. So how big is a micro? It's like 5K couple bytes of code. It's like 5,000 lines, 1,000 lines. Who can tell? What do you guys think? Well, usually what I do is when I have these kinds of questions, I go to Twitter and start to asking people what they think. So these are a couple of answers that I got when I was talking about microservices on Twitter. Well, you guys are laughing because you probably have those issues before. I like this one. And we have this one as well. I like this one as well. One day microservices will share some lists we call servlets. Okay, so this is also the size stuff. You're not gay, fam. You may not need to do that. Think about doing before you actually do microservice, because you may actually not need it. Architect's dream, developer's nightmare. Also like that one. Anyway, microservices are here to stay, and actually that's the way I get talking to conferences. All right, so that's why I have to start doing microservices, even sometimes I don't really like them. But depending on what you want to do, of course there are advantages of using this type of architecture. You want to develop new features quicker, so you have, instead of having one big monolith, you have multiple teams working on different features, and you might be able to turn that super quick. You have smaller teams. Of course, this was popularized by the Netflix guys when they came up with the 2 pixels ideas for a team. And I'm not going to talk about pixels over here, but you get the idea. Scale service independently. That's probably one of the features or one of the gains that you get using this architecture that I like the most. And of course, everyone is deploying stuff in the cloud, so you have to be ready for the cloud, and you cannot be ready for the cloud if you're not developing microservices. Is that correct? Of course not. But let's everyone think otherwise. Okay, so what about MicroProfile? So who heard about MicroProfile before? Okay, a few people. wonderful. I'm starting to see a pattern over here, so I started to do these kind of sessions about MicroProfile maybe when it started up, or maybe 2-3 years ago, when you had like a room with 10 people. So now I'm happy that I have like a full room. So at least there's interesting on this. And you can think about MicroProfile as enterprise Java for microservices. This project is held on Eclipse, and it's a completely open source project. So I'm going to send a couple of links later, but you're also free to contribute and see what everything happened, because everything is done on the open. So that's really wonderful. Okay, so what about MicroProfile? So MicroProfile started up as version 1.0 in 2016, and it was composed with CDI, JAX-RS, and JSON-P. Sorry, this is probably a real, okay. And the idea is that you could have application portability across all the runtimes from all the vendors that implement MicroProfile, because MicroProfile is about being standard on doing microservices. That's something that I miss on the Java world. You have multiple ways of doing microservices, and most of the times you get locked into a technology, and sometimes you want to do all the shifting, and it's hard to do it with everything that was out there. So, and right now, and if you look since 2016 until 2019, all that was accomplished by MicroProfile initiative is currently on version 2.2, and there was a lot of specs that came out during that timeline. So we have configuration, we have fault tolerance, we have job propagation, we have health check, we have metrics, we have open API, we have open tracing. And all of these were made to help developers develop these kinds of architectures of microservices, because these are the actual things that you need to do these kind of applications, right? There are other things that are also in the pipeline. So reactive streams is one of the latest trends that are being done in MicroProfile, and that's being released standalone. So maybe it will become part as MicroProfile umbrella sometime in the future. We don't know, but there are other things we'll look at in the future. So why MicroProfile? Why we came up with this initiative? Especially because of slowdown of Java EE innovation, right? I'm not sure. Do you have any Java EE or Jakarta EE developers over here? Okay, a few. Wonderful. And there was a negative perception towards the technology. So who hates Java EE? I mean, feel free to say, it's fine. No worries. But there was this negative perception, especially because there was not many releases going on, a lot of time between releases, and they definitely were not prepared for all these microservices development. Now, if you look a little bit as well on how Java EE evolved, we see that on E5, on down 2006, from 2017, so we're talking about 10-year span, there was like multiple specs that were added, but in the last couple of years, from E7 and E8, we only got like 2 new specs, and most likely all of these specs were fought for the applications that we were developing like 10 years ago. Most of them were like those 3 tiers architectures, right? And they didn't even answer the issues that we had with all of these kind of new trends, especially the microservices world. So why MicroProfile then? These new set of standards they're trying to offer a guidance for every developer to develop these kind of architectures in the Java world. They also needed to evolve very quickly, especially because if you look on all these trends, and maybe they started like 5-6 years ago, probably people are doing a lot of different stuff that they were doing like 5 or 6 years ago. So the lifespan of a technology and the way you're doing things with these technologies, they evolve super quick. And it's basically composed of a community of individuals and communities and vendors that they give each on their ideas on what we should have on these specs to help all of these developers in this world, right? Now, one of the things that you have to realize is MicroProfile is not Java EE or is not Jakarta EE. Sure, it started as a subset of some of the specs, but right now you start to have vendors implementations that don't even ship EE specs anymore. So there are a couple of vendors that do ship with them, so you're free to use one or the other, and you can combine them, so they're interoperable. Especially because some of them have a subset. But one of the things is all the new APIs of MicroProfile, they will build with the set in mind that you're not going to have an EE environment behind you. So you're completely fit to use MicroProfile without any EE world. And that's a good thing, I believe, because usually people have a perception that EE is somehow heavyweight, which is actually is not really that heavyweight. But there is a lot of stuff over there that we don't need, so we want to shield all developers for that complexity and only give them the good things. So who's involved in MicroProfile? There's a lot of communities and vendors involved in this. So you have IBM, you have Red Hat, you have Oracle, you have Fujitsu, you have Payara, you have Tommy Tribe, and then you also have other communities like the London Java community, the So Java Brazil, so those Java user groups. And you can also join as an individual. So one of the things that I enjoy on MicroProfile is all of this sense of community and all of these bright people that you have on all of these communities and companies working together for the same goal. We already have 5 MicroProfile implementations, of course. So all of these, you can find a compatible version of a server or a serverless implementation, right, that give you MicroProfile capabilities. So you have Payara, Red Hat, Tommy Tribe, Fujitsu, Oracle, Kumzula, Hammock, and IBM. So you have all of these to choose from. And now you have Quarkus, probably I'm not sure if you have heard about this, but it's a new toy coming from Red Hat, which I'm really excited about. What I'm actually going to show here is the implementation, one of the implementations from Apache, which is Tommy. Who heard about Tommy before? Okay, most of you. Wonderful. Thank you very much. So I'm probably gonna skip a little bit the explanation. But anyway, Tommy 8, which is on a milestone release right now, milestone 2. It's a MicroProfile compliant implementation for version 2.0 and now working for version 2.2. So the difference is not that big between one and the other, just a couple of minor spec updates. So all of the major specs are already contained in MicroProfile 2.0. Okay, my first MicroProfile app, so let's try to do a couple of demos. So CDI. Everyone's familiar with CDI? Okay, most of you, wonderful. So I'm going to skip all of that. So CDI, JAX-RS, of course, you need to develop some microservices. You're going to need some REST services. Are everyone familiar with JAX-RS? Okay, wonderful. And of course, JSON-P, so I'm going to skip that. And I'm just going to show you this really quick sample, which is I have like a book resource over here. I'm going to try to implement like a bookstore. So I'm going to find the book. So I just implement my REST endpoint with those annotations, path and the get, and then use CDI to inject a couple of beans, or just a single bean in this case. Then I'll just create a JSON object out of my response. I'll just return it, and everything should be okay. So this is nothing really new, right? We were doing this for last 7-8 years. What MicroProfile did was just pick up what everyone was doing with this style of application, and then build stuff on top of it. So that's why they came up with picking up CDI, JAX-RS, and JSON-P, because those are the basics, foundations to actually develop a microservice application. Okay, so for the runtime, now another thing that usually people complain about was saying, okay, Java generally, or not even EE, is super slow. It's heavyweight. I don't like it. I prefer to use Node or something else. Sorry? No? You don't agree? About what?
I don't like Node.
Oh, you don't like? Oh, I don't like it either. So that we're okay. I'm just saying that's why what people tell me. And then I came up, okay, so I'm going to show you how lightweight it is, because I'm going to actually pick it up and I'm going to run it on Raspberry Pis. So if I'm able to run this on Raspberry Pis, I cannot be slow, right? I cannot be heavyweight. Do you guys agree? Wonderful.
Are you going to run them on one Raspberry Pi or a cluster of Raspberry
I'm going to run multiple services in multiple pies. So I actually have like a setup of actually 12, but that takes a lot of time to set up. So I have like the minimal version, which is 4 over here. So now the runtime, I'm going to run stuff on my local machine. I'm also going to run stuff on the pies. And if you have a couple of pies across at home, feel free to try this out because I think this is super fun. So I'm actually able to run stuff in the pies with Docker and then push everything using Ansible to the pies. I mean, there are other things that you can use, but this is the setup that I choose to do it. And well, Raspberry Pi that I'm running over here is Raspberry Pi version 3, so it's not the latest one because I think they released a new one a few months ago. But anyway, there is this thing called IPJOS, and this is a very interesting OS for the Pi because some guys that just pick the Debian distribution and they just optimize that distribution to run Docker. So that actually means that you can run Docker in the Pi. Now, there are some limitations, of course, because the image that you have to run on the Pi has to come from an ARM-based image. So they also ship a lot of other Docker images that you can run with the ARM. If you don't have it, you just have to build your own. But for instance, for the JDK, there is, of course, some images you can run directly with the JDK with an ARM base image, so that they are perfectly fine to run with the Pi. And they have images for Nginx, Postgres, and console, and a couple other things. But if that doesn't work out, you can just roll your own. Then in my project, I'll use Maven Fabricate to plug in to generate the Docker images, which probably is pretty standard, right? The only thing that I did over here was I set up a local Docker registry to push my images to my own box and then feed in those images to the Pis. So I don't use Docker Hub in case I don't have Wi-Fi, or I have a slow connection. So it will be easier to speed up the deployment and development. Well, and finally, I use Ansible just to automate all the tasks to run on the Pis. So let's see how this goes. So let's move over here, and I have. So I'm going to do a ping to the Pis using Ansible. Okay, everything is green. So I'm just going to disconnect the cable so you guys see that this is not. This is actually real. Sometimes people don't believe me. So now you see that that's not timing out. In the meanwhile, I have now my application. So my application, I show there the book portion of my store. But of course, on the microservices, we don't only have one endpoint. We have multiple ones. So this is the more complete version. And what I'm actually going to do is I'm going to start with this one, which is a number resource, which what it does is just generate a random number to create the SBN of the book for my bookstore. So this is the one that I'm going to deploy first. And of course, I can just build it here directly first with a simple ambient clean install. Well, I'm just going to do this shortcut. Oh, now it's failed, that one. So let me hook up this cable again. And I'm just going to run this on my local box. So one of the things that I've done over here is I'm running Tommy as a fat jar. So it's a very popular approach one of these days. And I just run that jar over there. And now my service is running. Hopefully. Yeah. And I can just curl it. So this one is running on localhost 8080 number API. Let's see. numbers generate. Oh, sorry, 8081. Okay, so let's take that out. Yay, wonderful, right? Very well, so now, well, let's do that on the pies. So I'm going to do this Ansible playbook. I already have my command over here, so make it easier. Services. Okay, let's do it that way. And what this actually does is I already generated the Docker image. It's done on the build. So if I do a list of Docker images, I'll have here my MicroProfile MP samples, book API, number API, and there's a tag for the Raspberry Pi image. And now if you look on the YAML that I'm using to deploy, which is the service YAML, so now it's using the Docker Ansible plugin, which basically what it does, it picks up the Docker image from my local repo using this Docker-registry running on this port, and then it will just push this image to this host name, which corresponds to a Pi, and we'll do the deployment over there. So now it's done. So if I'll change these and I'll see, so my number API was deployed on, actually was deployed on two servers, Pygram 1 and Pygram 2. So if I change this, now it's over there. See how fast it is? It's running on the Pi. Well, it's just a random number. It shouldn't be too slow, right? Let's do it on the 2. So there we go. Well, let's disconnect a couple of cables here again. Okay, so I got nothing. Do you guys believe I'm running these on the Pis? Okay. I should get, yeah, you got it right now. So let me, actually I can Google, I can SSH them. There you go. Oops. I think I got it wrong again. Yeah. Okay, there you go. So now you can see I'm on this IPOS, and now if I have Docker here on the Pis, and I can see the Docker images that I'm running. So that was the one that I was showing, the number API endpoint. It's up and running over 2 minutes, and of course I can do like Docker logs and see what's happening on my server and all of these things, which is pretty cool. Who finds this pretty cool, actually running stuff on the Pis, right? Wonderful. I actually develop all my stuff on the Pis. Okay, I mean, this was like super simple, I believe. So I mean, we have like a simple endpoint. I developed like a simple app. I was able to run it on my local box, and I was able to run it there on the Pis. And of course, this is super interesting when we're running stuff on the cloud, because we have multiple environments to be able to have our application to run. But now what I'd like to show is how you can evolve your MicroProfile app. And I want to start adding more specs, and I want to go over all the specs that we have, so we can enhance the experience, and we can see what we can accomplish with the rest of the MicroProfile specs. So the first spec that actually came out was configuration, and of course everyone needs configuration to change the running behavior of an application. It can be, for instance, you want to do it for changing the currency of the application, or you want to change the username that you're using to connect to a particular database. It doesn't really matter. But the issue is that you really need a way to configure the application externally, so you can change the behavior from environment to environment, so you don't have to repack the application all the time. And this was basically based on Delta Spike, Tamara and Tamaya, and Sabot, which were a couple of libraries that people were using before coming up with the spec. So how does this work? You have a MicroProfile config properties that you can add in your application, and you can default to the configuration that's over there. But you can also use environment properties or system properties that you can feed to your application externally. And if you're not happy with these, you can roll your own. So I wrote a blog post a couple of weeks ago that show how to implement a config source to read information from a database and set up all the config sources in that way. So what do we want to do over here? This was working fine when I want to generate my number, especially when you have microservices and you have to set up, for instance, endpoints. It works fine when you're on a local host, but when you have like multiple deployments on multiple machines and you have to set up different endpoints. In most of occasions, you probably should use a service discovery to do that, of course. In this occasion, I'm just doing configuration to provide that endpoint. And in this particular case, you can see you can just inject as a CDI property using config property the configuration. So it'll have it work as a map. You have a key and you have a value. You can feed already default values directly on the annotation, or you can use it programmatically. So you can just call the API config provider get config, and then you can grab the config properties from there. The idea over here is there is for all the config sources you have, environment variables, system properties, things in a file. You have a priority queue. So if the config provider doesn't find that on environment variables, it falls back to system properties. If it doesn't find the config variable over there, it falls back to the MicroProfile properties file. And if it doesn't find something, it will just fall back to annotation. So it works as a set of priorities, and you can play with that. I'm not going to show a demo of that because I think it's fairly easy. Metrics. So metrics, I think it's an essential part of building microservices, especially because you have so many servers lying around. You have to monitor them and see what's happening with the service. So you want to monitoring what's happening. Now, what metrics gives to you as a spec, out of the box, you have endpoints that the application starts up with that allow you to retrieve metrics information for the application being deployed on a MicroProfile server. You have three endpoints that you can use. You have base for compliant servers. You have a lot of information. I'm going to show an example of that. You have applications, so you can implement your own metrics and expose them as an endpoint so everyone else can query. And you have vendor, that these ones are for specific server information that you want to use. You can also use the options HTTP methods, so you can grab the metadata to see how you can read the JSON. So the JSON that you receive is pretty standard, so you have to look into the spec on how that is done. But the idea is that you have units of measure. It can be time or something else, or units. And then you'll just use that information to parse what you get. So for these particular samples, let's see. So let's exit that one, and I should have these ones are the ones that we're doing. So yeah, let's. So this is. So now, this one I'm just querying the one that I have on my local box running, and you have that metrics over there. So that's probably not really good. So let me run one of these. I should probably memorize these commands, but they are quite, or actually make analysis for them. So this should be better. Okay. So now you're happy to see a pretty basic information of your system. For instance, you have the class loading information, you have garbage collector information, you have memory information, which is somehow useful. If you do it like that, usually if you do it like that, you get all of them together. So you get the ones that are based, the ones I showed before, the one that's vendor, and actually the one that I have over here, which is an application, is one that I implemented to track how many number resource I generated as a metric. So I have 9, and I get the rates which I called over there. So if I show this in the code, it's just as simple as, so not that one, not that one. So let's go over here. Okay. So I'll just use the meter as annotation or the time as annotation, and that will give me 2 new payloads that will monitor this endpoint on those /application endpoints. And one of them will just meter the amount of calls, and the other one will just, it's going to time the calls. So if I now do a couple of other curls over here on my local host. So remember, we have 9. So if I do this one again, we should have more, I have 14. And now I can see how long my service is taking to run, how many calls I've been doing. So I think it's pretty useful information, and you get these almost for free just by adding a couple of annotations to your endpoint. So I think it's pretty cool. And of course, I can, if you don't also believe me, I can run this on the Pis, and I'll have the exact same thing. Oops, maybe not. Number API / metrics. No, JSON could be decoded. Well, let's do it like that. Maybe something is not right now. Server 1, 404. Wait a sec. This one, 8081 numbers API generate. Let's write the number 2. Oh. Okay, never mind. I have to check that out. I mean, it will never be a real demo if it doesn't work out, right? Okay. Carrying on. So this is just a couple of samples of the metrics. And this is how you implement that just with those annotations. And of course, you have a few others that you can use. You have gauge and a few others. So you just have a look into the examples and you'll see what you can do. Another thing that you get for free is health checks. So health checks allow you to probe the state of how the application is up, if it's running or not. And of course, this is interesting because you might want to use this information to start up a couple of other servers if yours are down, or maybe you just check the if a certain endpoint is up before sending calls or any other payloads to that server. So the idea is that you can use this information to automate decisions depending on your business needs. Again, when you deploy this on a standard MicroProfile server, you get the /health and then endpoint for free, directly deployed with your application that can report the health check of the server. So again, if let's go over here. Now if I do this again, so I'll do health, and let's do localhost over here. 503, so I have it down. And why do I have it down? I have it down because, do you see that I have like some check over there? The audience, are you guys awake? Maybe? Let's try it again. It's still down. Down. Oh, now you're up. Now I'm up. Okay. And this is because I implemented here a check audience isn't sleeping, which basically just returns a random. Yeah, you might be sleeping or might not be not. And notice that what I did is I used the health annotation and I implemented an interface called health check, which basically gives me the method that I have to implement to do the health check call. And if you implement all of these, they will be called as part of the health endpoint. So if you don't have it, it will just call. If you just call for the server and see, okay, if the server is up and running, it will just return an up. But if you have additional checks, you can implement it in this way, and they all be part of your check. The idea here is, if you have multiple ones, the health check of the server is going to be up if all the health checks are also up. So that's why I have a random over there, and sometimes it's up, sometimes it's not, depending on the random. But this is useful. For instance, I used to have one that will check for disk space, right? Because I'm pretty sure all of us already had servers crashing because they run out of disk space, right? And this is health check. So you can just use your imagination to implement all kinds of health checks now using this API. So this is an example. So fault tolerance. So fault tolerance, it's for you to implement a strategy to guide the execution of a result of a piece of code. And this is most known to people as using a circuit breaker. But there are other things that you can use with the circuit breaker. Of course, you can time out the endpoint. You can do a retry if you're not able to call that endpoint. You can fall back to another piece of code. It can be something local, can be another endpoint, and so on and so forth. So you get the idea. So this is heavily inspired by Eastrix and failsafe. Are these concepts familiar to most people over here? Yes? Okay, wonderful. And it does support synchronous and asynchronous execution. So I'm just going to showcase a couple of calls using just synchronous execution. Again, the idea is you will just annotate your code with some of the annotations of the spec, and you have one called circuit breaker. So that means that you want to break the circuit if this is not answering properly. And then you can add a fallback saying, okay, if this doesn't work out, I want to fall back to this piece of code. So in this particular case, now I'm going to. So I'm just going to kill this one that was running number, right? And I'm going to move to my book endpoints. That one's already built, so let's just run that one like that. And now on my book, these book endpoints, I can create books. So I'm using the number API to generate my ISBN number. But as you can probably tell, I don't have a number API running. So what's going to happen in that case? So let's see. I should have here. I'm super lazy, so I usually do it this way. This one is not going to work, but I just want to copy the command. And I'm just going to replace that one for localhost. And it takes a little while, but I got the 201, right? And if I do a curl v stp / well, it's always easier if I do it that way. And let's remove that one. And I get the 200 of a list, so probably let's take that V out of there. It's probably messing things up, okay? And I get the fallback number, right? So if you look now into the code of my book API, I have my book resource, right? Which injects a number service, and that number service is the one that retrieves the SPN number for my other endpoint. But this number service is annotated with a secret predicate and a fallback. So if I'm not able to run this properly, I'll just get a number fallback, which will generate that random string fallback number. And of course, I mean, this is probably not the best fallback in the world, but maybe you can then have some job that will just go to all the books that have a fallback number and just replace them later. Just an example. Hopefully, if I can do that over here. Well, let's open a new one. Now it's super small, doesn't matter. Just for me to run the number API. Okay, so now I'm running the number API again. So hopefully, if I go now and try to create a new book, I should get the proper number. So that one was here. So let's do a post again. So now I got 2-1. Notice it was way quicker because I didn't have to wait for the timeout that I had. Now if I do a list, now you'll see that I have, let's clear that out and put it on top of the screen. Now you'll see you have that one over there. I'm going to try to do that on the pies as well. So I run that on the services, right? So that one was running on localhost. So I should be able, so I think this is on Pi, Grom, database. Okay, so apparently I have already a book over there. And if I do, I already had a couple of posts of books. So let's do a history. Pygram, okay, 534. Okay, I got a 2-1, so I'm creating books on the pies. And let me list them. So I have multiple books over there. So now I'm going to disconnect the number API that's running over there, which is communicating the things. And let's try to create a couple of new ones. So now you'll see it's taking a little bit longer because we're waiting for the timeout, but still it was able to create with a 201. So let's list them. And now you have a fallback number over there. So let's connect that again. And let's post a few more. Now it's way quicker. And let's list them. Okay, so now you have again some numbers. You still have the fallback number from a while ago, and everything is running fine. So you see, it's. I'm not bullshitting you, right? So it's not like you have a VM or you have services putting up and down. I'm actually going there and disconnecting cables, which is most likely what's going to happen when you're running something. So it's quite interesting to actually see this running on a live cluster. Okay, so let's carry on. Okay, JOT propagation. So of course we need security to secure microservices, and we give security using security tokens, namely JOTs, using OAuth2. And it's a lightweight way to propagate the security context across all the microservices chain. So I'm not going to do a demo over here because I have to do a quite setup to do that. I mean, I could have done it by just creating some things programmatically, but it's more interesting to have a token store and create the JOT and then use the JOT to authenticate. I've done that on other sessions, and it does take a while. But the idea over here is you can use those annotations as @inject and @claim. If you get the JOT coming on your request, then you can use the JOT information to actually authenticate and authorize endpoints on your application. So the server, of course, will have, you still have to provide the public key of the OAuth2 token store, and the server will validate that key automatically for you when it's receiving the request. If it's fine, it will just forward the request to your endpoint. If it's not, it will just reject the request with a 401. And then you have a couple of ways to use it. So you can just use a roles allowed annotation. It will use roles that coming from the claims in the JOT token, or you can just use it programmatically, use user in role. So there are multiple ways to do it. Okay, open tracing. So on open tracing is also an interesting spec. The idea is that you will use open tracing to trace the request across your multiple services, right? So especially on these microservices role where you might have like 1, 2, 3, 4, 5, as many hops as you want. So you want to track what happened during that chain call. The idea is that you will use open tracing to trace all of that request and all of that call to see if something goes wrong, what went wrong. So I'm not going to do a demo on that because I did try, but I was having a couple of issues with the implementation. Well, the implementation works fine, but I was having a couple of issues with Zipkin to basically actually have all the information of the tracer. But the idea with open tracing is if you want to trace an endpoint, you'll just use the @trace annotation, and it will automatically create a package bag that will monitor some call information to add to a monitoring service like Zipkin. And then you can even inject a tracer object to inject your own payloads to also be monitored and added to an open tracing implementation or open tracing compatible server. So that's the idea. So then you use like the after span set tag to tag the payload or the bag, add logging, and so on and so forth. OpenAPI. OpenAPI, of course, you cannot have microservice without proper documentation. At least we hope so. The idea is that you will use OpenAPI to expose documentation with your endpoints, and it's heavily based on Swagger too. So I'm guessing most of you are familiar with Swagger, right? Yes, and OpenAPI. Okay, a few less, but I mean it's exactly the same thing, just a couple of annotations that change. And this is just a sample. So if you do like operation find book by ID, so that's the summary, and they have like an API response. So let's try to do it here super quick. History, so I should have an open API, number API, metrics. Okay, so if I do that one, now you'll see that you have a YAML response of my endpoint over there for my bookstore service, and this one it's also for free. So you'll still get that one when you deploy application on MicroProfile endpoint, and you can enhance your documentation using those annotations. Okay, RestClient. So RestClient has a way to have a type safe feature to implement REST endpoints. So I'm not going to do a demo of this. I'm running out of time. But the idea is that it extends JAX-RS to APIs, and it's very similar to Feign, if you know about that. You will use, for instance, an annotation called register REST client. You'll just implement an interface that's the exact call that you want to call for. So it looks like an interface for your service, but it's actually an interface to call a client. And then you can just do @inject REST client, and then you can use client to call another API using a find by ID, and the server will just generate all the code for you to call that endpoint, and that's it. Okay, so I done a couple of samples, but how if you want to start it? So you can go to this website called startmicroprofile.io. I'm going to try to show it super quick. I want to do them on this, but I don't have really time. So you can just come over here to this website, and you can start your group ID, your artifact ID. You can pick up the microprofile version that you want. You can pick which server. Now I don't have Wi-Fi, so it doesn't work out. But you can pick which server you want, and then you have the specifications you want to include. And this will generate a jar or a web application and you can just download it, and then you can just import it to your IDE, and that's it. So I mostly run out of time, so 30 seconds, MicroProfile 3.0, it's coming in 2019, major updates to Health and Metrics. There's also plans to have GraphQL, long-running actions, concurrency, reactive messaging, event data, and reactive relational DB access. If you want to get involved, you can join the mailing list on Google Groups. And these are some of the resources. So everything regarding to MicroProfile you can find on microprofile.io. And if you want to contribute, please join the initiative, and we'll be happy to have you over there. So thank you so much for joining. And if you want to take any questions since we're out of time, I can do it right side of the room. So thank you very much.